Hello everyone. Today we are going to discuss the second algorithm in the association rule mining, that is ARM. The first one was the a priori algorithm that we have discussed in the previous video. To overcome the disadvantages or the drawbacks of a priori algorithm, we have the second algorithm, that is the FP growth or the frequent pattern algorithm. So what basically is happening, that I can shunt out the items that are giving me a value. We have a minimum cost, right? Suppose my minimum cost is 2. What does this mean? This means that the item should be purchased at least 2 times. Only then it will remain in the list of patterns. Okay. So first of all, what I will do in this method, I will arrange, suppose this is the minimum support count for item 1, item so on up till item 7. Okay. For I1, 1, 2, 3, 4, 5, 6. It has been purchased 6 times. Item 2, 1, 2, 3, 4, 5, 6, 7. Item 2 has been purchased 7 times. Item 3, 1, 2, 3, 4, 5, 6. Item 3 has been purchased 6 times. Similarly, I'm sorry, there are no items 6 and 7. We just have 5 items in the transactions. Okay. So now I will arrange them in the descending order. Okay. So I have I2, then I1, then I3, then I4, and then I5. 7, 6, 6, 2, 2. Now what I have to do, I have to make a FP tree. So how I start is, the root node for my FP tree is always null. Okay. And I always make the nodes in such a way that the node with higher minimum cost will come at the top. Now I see transactions one by one. So the I2 has a maximum minimum support count. So I will make one of the nodes as I2. Okay. Now my next step is to look at the transactions one by one and then make them in the tree. The first transaction taken is 1, 2 and 5. 1, 2 and 5. So the order does not matter. 1, 2 and 5 will be taken as 2, 1 and 5. So 2 has already been taken. Why am I writing 1 over here? This 1 signifies that item 2 has been purchased 1 time till now. So 2, 1 and 5. Okay. Now next is 2, 4. I start from null. I take item 2. Then if I go here, I'll obviously need to item 1 and 5. I don't need these. I need item number 4 after 2. So 2 and 4. Item 4, again 1. Then I need 2, 3. If I go from item 2 to these two places, I will not get 2, 3. I need 2, 3. So I make a new node over here. This is also traversed one time. One more thing that you need to do is side by side. After transaction 1, I2, I5 and I1 had value of 1, 1, right? 2, 4. This path is once again traversed. That is, this node is traversed once again. Why 1 plus 1? For the first transaction, the items bought were I2, I1 and I5. Okay. So this one was for that. Now again, when the second transaction took place, the items purchased were 2, 4. That is, I2 was purchased one more time and item 4 was purchased along with it. When transaction 3 took place, that is 2, 3. So what happened? Item 2 was again purchased and along with it item 3 was purchased. That is how it is going on. When transaction 4 took place, 1, 2 and 4, that is, I have to take 2, 1 and 4 in this order. So 2, item 2 once more. Then I will take item 1 and then item 4 be taken once. Okay. Then why this path? Because 2, 1 and 4. Why do I have to? That's not necessary that I will write down always take a new node for a new transaction. No, if there's something overlapping, I can obviously take that. And why did not I take this one path? Because I4 has a lower cost than I1, so I1 has to lie before I4 in the tree. I cannot do this. I cannot write I1 over here. This will be wrong. I have to write I1 over here because I1's cost is 6 and I4's cost is 2, and so I4's cost is lesser, so it has to lie below I1 in the tree. Next is transaction number, I think it's 1 comma 3. So 1 comma 3, I there's no 2 involved in it. From null I'll have to take another node I1, then I3. Why from the beginning? Because my only items are 1 comma 3. I don't need 2 in it. Okay, now next is 2 comma 3. So once more 2 comma 3. This is traversed once again, this path 1 comma 3. So 1 comma 3 is taken one more time. Okay, then 1 2 3 and 5, that is 2 1 3 5. So 2 1, no, this is not possible. 2 1, I'll have to make a new path, right? So 2 1 I3 and I5. Okay, and then 1 2 3, that is 2 1 3. So 2 1 3, and I stop over here. So 2 1 3. Now I'll write down the counts. Okay, this is 2 2 1 1 1 2 3 4 1 2 3 4 5 6 7. So now for I2 the value comes out to be 7. For I1, let's calculate for I1. For I1, let's find out 4 5 and 6. So for I1 it comes out to be, let's write it down over here. I2 it comes out to be 7. I1 it comes out to be 4 plus 2, that is 6. For I3, let's see. I3 is here 2 plus 2 plus 2, that is again it comes out to be 6. Then for I4, if I see 1 plus 1, I4 is 1 plus 1 is equal to 2. Okay, and then I5 is 1 plus 1, that is 2. So this is not something related to your numerical. It is simply a way of confirming that the tree that you have drawn is correct. If these values come equal to these values, then obviously your tree is correct. Because how we had made the trees? We had made the trees using transactions and these values. So when I'll verify my tree, what I have to do? I have to see how many times each node is traversed by using this thing, and then I'll tally with these. Okay, so that is how I see that the tree that I've made is correct. Now the next step is the conditional base pattern. So the next step is finding out the first step was arranging them in the descending order, sorry. The second step was making the FP tree. The third step is making the conditional base pattern. Okay, so we have to start from the node which has the minimum support value. Minimum support value is of I5. So we will start from here. Okay, and we will not include the node. I'll write it down for you. Start from the node with minimum support value. Exclude the node with maximum support value, that is I2 over here, and this one is I5. Okay, so Now what I'm going to do, I'm going to find out the paths for each node from null. Okay, that is from null. How many ways are there that I can reach that particular node? So let's find out. Using the graph, first of all I find for I5. Then this is the conditional base pattern. And here I will write down the conditional FP tree. So for I5 I can reach I5 from I2 I1. Okay, and how many times this path is used? Only one time. How do I come to know? I come to know from the transactions. I2 I1 comma I2 comma I5, this path is used only once. So I reached I5 using I2 and I1 only one time. Okay, this is the number of times the path is used. This is the path to reach node, this one. Okay, I hope this is clear. Once again I'll repeat, this is the number of times the path is used. Which path? The path which covers the nodes I2 and I1, and I have to reach I5. I have to reach I5 from the starting node is null. I started from null. I reached I5 using I2 and I1 only one time. Okay, so the next way to reach I5 is, if I see from the transactions, it's easier to see from the transactions as compared to the graph, so I'll be seeing from the transactions. So I5, the another way is from I1, I2, I3 and I5. So I traverse this path I2, I1, I3 and I5. So I2, I1, I3, and I reached I5. This path is covered only once. This path is covered once. I started from null reaching I5. Okay, so first let's make all the conditional base patterns for all these things. For I4, let's look at the transactions. 2 comma 4. So from I2, this path is taken one time. Then for 1 2 4, that is I2, then I1, then I4. This path is taken once. Then I took, okay, there are no other transactions, so I4 is taken only these many number of times. Then comes the turn for I3. Okay, so and you might be thinking in which order I have written these I have written in increasing order of their minimum cost count. 5 has the minimum, so I have written 5 at the top. Then 4 also has equal to 5. Okay, then I wrote 4 after it. Then 3 has a support count, or you can say minimum support count. This is actually the support count, or you can say the cost, support cost, whatever. So I3 has a minimum support cost of 6, which is greater than that of 4 and 5, so it is after that. So I3, if I look at the transactions, I3 I reach from 2, I reach from 1. Reaching I3 from I2 is covered 2 times, right? Yes, is covered 2 times. Once here, once here. So this is 2. Okay, then reaching I3 from I1 is also 1 2 times. Okay, then I see from those paths where I see for where I2 and I1 both have been used. So wait, let me see. This transaction is done. Reaching I3 from I2 is done. This is done. This is done. This is also done. The transaction that is left, or those are left, are these two. Okay, so that is I reach to I3 using I1 and I2 2 times. Now one thing that you have to notice here is that this transaction belongs to one subtree. Okay, and these two they belong to same subtree. Okay, so that will make a difference in the this thing conditional FP tree. We'll discuss just in the coming part of the video. Now we have to make for the last, that is the I1. Why we have not taken I2? Think. We just said that we do not take the item with the maximum support count. We do not take the item with the maximum support value or the support count in the conditional based pattern. So I2 is the item with maximum support count, so we will not take it. Okay, so you can, okay, so I1, I can reach I1 from I2, then directly also I am reaching. Okay, yeah, that's the only way, because okay, so I1 is reached only from I2. How many times? 1, 2, 3 and 4, that is 4 times. Why have I not taken this transaction? Because when I look at my graph, do I need any path or do I need to travel? What is the, actually just try to understand what is my motive in this thing. I have to check that I am starting from null. Okay, I have to reach this node using this path. So when I have to reach I1 from null, when I have to reach I1 from null, do I need some other path? No, I am directly reaching here. So I do not need to consider with I3. Okay, so one thing that you can keep in mind is that the value or the item number that will be taken over here will be greater than this one. That is, the cost for the item will be on this side will be greater than the cost of item on this side. That is why I have not taken I3 over here. Okay, so that's a way of learning, but if you have to understand it logically, the logic is that I am starting from item null and I have to reach item 1. So I am, obviously it is very clear from the graph that I do not have to take any node in between, and a node, since my graph was made in the descending order of the minimum counts, or you can say the minimum support values, so the item with the support value lesser than I1 will not come in its path. So similarly I have taken over here, but the only thing that you need to remember is that the items taken on this side will have a support value greater than the items taken on this side. Now our job is to make a conditional FP tree with the help of the conditional base pattern. Now we take individually. What do we take individually? See, I2 comes how many times? 1, 2, 2 times. I3 is taken as only 1 time, and I1 is also taken as 2 times. So that means I will discard this value because it is lesser than the minimum support count value mentioned in the starting, that was 2. Okay, so the next is this one. I2 comes out to be 2 times, I1 comes out to be 1 time, so this is discarded. Now in this subtree, what happens is that I have to denote it in a a simple but a bit special way. So what I do is, I'll simply write down I2 comes 1, 2, 3, 4, 4 times. Okay, and I1, now I do not write I1 as 4 times because this is a part of one subtree. In this single subtree, I1 is coming only 2 times, so 2 times, and this donates, the angular brackets, they donate that this is a part of one subtree, and I write down I1 is equal to 2. This is for this one which belongs to the another subtree. So the items of one subtree are taken like this and the other subtree are taken separately. Here nothing is discarded again, and here I2 will be taken as this only. So that is how we are making the conditional FP tree. Basically what we have done, we have seen that individually which item is purchased along with the item on the left hand side. So now the last and the final step is to make the frequent pattern. That is actually that I require. Okay, that is I have to make a combination. Now how we'll make that, we'll just discuss. We'll make that using the conditional FP tree. So here we proceed. Now for I5, what I do, simply I have to collaborate these, that is I2 with I5, I1 with I5, whatever is left. So I2 with I5 will give me 2, I1 with I5 is giving me 2, and yeah, that's all about it. And the third combination that is taken is I2 comma I1 comma I5, that is also 2. So what I did, the two items left over here, that is I2 and I1, okay, and then a combination of these. Basically we are combining all the items. So, and for I4 it will be similarly I2, there's only one item, I2 with I4. So I2 with I4 is equal to 2. Now we'll discuss for I3 later on. Let's first do for I1. I1 will be simple. I1 will be I2 comma I1 with 4. Now let's see for I3. I3, the combinations are I2 comma I3, okay, I1 comma I3, and I2 I1 comma I3. Now for I2 comma I3, it is obvious that the combination is 4, combination answer. For I1 comma I3, the answer is again 4. But now for I2, I1 and I3, I have to see what will be the answer, whether it will be 4 or it will be 2 or anything else. So what I do is, suppose I have a path from, let us understand this with the help of an example. I have a path from city A to city C via city B. So I say that I go from city A to city C 4 times. A to C I have gone 4 times. But using B, I have gone only from B to C, I have gone only 2 times. That is, I went from city A to city C. Okay. And via B, I went only 2 times. What does that mean? That means the rest of the times A took some other path to go to C. Out of 4, when only 2 times A took this path, other 2 times how did it reach C? It took some other path. So similarly, what I will do here is that I am saying that item 2 is here. I am taking it with the help of this thing items. So I am saying that item 2 is purchased 4 times along with item number 3, and item 1 is purchased 2 times. 2 times with item number 3 in one subset, and 2 times with item number 3 in another subset. So basically I have to take a minimum of these. So here the minimum comes out to be 2. Out of 4 and 2, the minimum comes out to be 2. I will write down 2 over here. I hope this example is clear. Okay, on the basis, logically the concept is this, and if you have to see for the numerical, or you have to write down the answer, you have to simply understand that you have to take a minimum of the given two values. Okay, so here the values were that came out were 4 and 2. Okay, so you took 2 over here, which is the minimum. So that's all about the FP growth FP tree, or you can say FP growth pattern. So let's revise it once, because you know, the advantage is that we keep on removing the useless combinations in the beginning only. Like here we remove these combinations. Okay, so this is the advantage of a priori. The first step is arranging the given items support cost in the descending order. Then we made this thing FP tree. So FP tree was what? How many items has occurred how many number of times. We verified our FP tree with the help of the ones that we have written over here, that they are the sum of these ones was matching the given minimum costs that we had calculated with the help of our transactions. Okay, so the next point is calculating the conditional base pattern. Two things we have to take care in this. We have to start from null and we have to reach a particular node using this path, and this path is used how many number of times? These many number of times. So this is the basic about it. Then we have to form a conditional FP tree. What is a conditional FP tree? This takes all the items individually with the item on the left hand side. Okay, and then those items which do not reach or which do not support a minimum support count, they are crossed. So this is the advantage over a priori. And then we have the final step, that is the frequent pattern. So in the frequent pattern, what happens? We see you make the frequent pattern or the final result using the conditional FP tree. What is happening? I have combined my result. I have made a combination of results. So what is happening is I have combined I2 with I5, then I1 with I5. I have combined all the leftovers with the items on the left hand side. So that's all about it. Thank you for watching. I hope you liked it. If you have any doubts, please feel free to ask, and you can mail me at lastminutetutorials.com, or you can also mention below in the comment section. Your queries and suggestions are really beneficial for me, and do like, subscribe and share. Okay, thank you for watching.